Let's take a look at Newton's second law. Newton's second law tells us if we apply a force to a mass, we're going to cause that mass to accelerate or change its velocity. You might also see this equation written as the net force, or the sum of all forces, equals mass times acceleration. Each one of these equations is saying the exact same thing. If you take all the forces on an object, it will cause a mass to accelerate. So let's take, for example, a block with a mass of 10 kilograms. If you don't apply a force to that block, then nothing is there to change its speed. Nothing is there to cause acceleration. Let's say you apply a 10 Newton force to the right and a 10 Newton force to the left. Well, logically, those are going to cancel each other out. If we follow the equation, the sum of forces is equal to mass times acceleration, or 10 to the right plus 10 to the left is equal to mass times acceleration. So these cancel each other out. 0 equals ma, so our acceleration is equal to 0. But what if we only had one force? So now let's say sum of forces equals ma, or F equals ma, where our force is 10 newtons and our mass is 10 kilograms, and we're solving for acceleration. Here we can see if we divide both sides by 10 kilograms, we get 1 meter per second squared is equal to acceleration. And since our force is to the right, our acceleration is going to be to the right as well. So if this object were starting at rest, initial velocity is equal to 0. The velocity after 1 second is going to be 1 meter per second. And that's because our speed increases 1 meter per second every second. Acceleration is 1 meter per second every second. And at t equals 2 seconds, our velocity is going to be 2 meters per second, and so on.